You need to be on page 54 with me. And let's do a few. Yeah, y'all watch the Harry Potter weekend too? Oh yeah. Too many commercials though. It gets annoying. All right, so let's get to work. Now, if you remember, to find the limit of a function, the limit is the number that the function values are getting closer to as x gets closer to a certain number. So, for this problem, as x gets closer to 2, all right, that's what this notation means. The limit as x approaches 2. So as x gets closer to 2, what does our function value get closer to? Now, this is our function value. They didn't write it out. They didn't say f of x equals x minus 2 over x squared minus x minus 2. We're supposed to understand that's what they're talking about. Okay? Now, get out your calculator. And let's learn how to make these tables on our calculator. All right, so go to y equals, and you got to use parentheses. You got to put parentheses around your x minus 2. And then close the parentheses. Then divided by, and then you got to do parentheses x squared minus x minus 2, and close the parentheses on that. Okay? Now, we're going to go to our table. So if you just, let's see, if you just go to your table right now, it's got things on there you don't want. We don't want to know the value of, we don't want x equals those particular values that I have there. So here's what we do. Go to table set. Make sure your independent variable is set to ask. All right, so table setup, table set. Set your independent variable to ask. That way, you get to determine what the x values are. The calculator asks you what values you want. Okay? Now we can go to table. And I'm just going to delete out these old values. So get your table looking something like that. However it looks on your calculator, it looks something like that. Following me so far? All right, so first x value we want is 1.9. So type in 1.9 and hit enter. So at 1.9, we get 0.34483. So we fill that in the table. Next x value we want is 1.99. So you type that in. Oops, don't put the negative sign on there. You hit enter. You get 0.33445. Yes? All right. 1.999, 0.33344. What do you think it's converging to? I think it's converging to a third. I think it's going to 0.33333. All right. But then they want us to, instead of keeping on putting nines on there, they want us to jump to the other end. Look, I'm going to jump all the way to the end, 2.1, so that I can see it converge and see if it's going to converge to where I thought it was going to. So I'm going to go to 2.1 and get 0.32258, and then 2.01 and get 0.33223, and 2.001, 0.33322, Sure looks like we're going to 0.33333333, which is an approximation of 1/3. So here's my answer. And those are three little dots. I mean, therefore. And you need your table because this table shows me something. I look at the table. Therefore, I conclude that the limit as x approaches 2 of x minus 2 over x squared minus x minus 2, the limit equals 1/3. Now, curiosity is getting the best of me. I just got to see what happens when I type in a 2. I just got to know. Okay? So, like we talked about on Friday, you know, it could be that the limit does equal the function value, but that's kind of boring when that happens. In this case, and we haven't graphed it, so I don't know what it looks like, but this function does not exist when x equals 2, does it? I don't know if it's a whole. I don't know if it's an asymptote. I do know that the two ends come to meet. It's not where, you know, coming from the left you get one thing and the right you get the other. And again, I don't have to do it to solve this problem, just curiosity. I wonder what it looks like. That doesn't seem right. Unless I got a hole right there. Oh, I missed it, didn't I? Zoom out. Now let's start over. All right, so I got that. I'm not very good at my zooming. If I zoom in, I want to zoom in around X. That didn't work. I don't make it zoom in where I want it to. I can just change the window. I can go from 1 to 3. See what that does. That didn't do anything for me. I can trace it. About all I can do. Y'all are probably. I hope you're better at doing this than I am. So when I'm tracing along here, as x is getting closer to 2, y is getting closer to 1/3, then all of a sudden it doesn't exist, then it does on the other side. So there must just be a little hole there, right? Okay. Any questions? Okay. No. Number 7. Now this time, we're finding the limit as x approaches 0 of the sine of x over x. All right, now, on your calculator, make sure that you're in radian. All right? So you may have to switch back and forth between this and your science class if you're using it in there. But here we need it in radian. So I go to mode, and I'm in the wrong thing. So I would have gotten everything wrong if I didn't check this, because it would be in degrees. We're always in radian in here. So radian, highlight it. Everybody in radian now? All right, we will always be in radian in this class. If you're getting weird answers compared to what the book has or what I have or what your friends have when we're doing trig functions, you're probably in degree instead of radian. Okay? So check that. So let's see. So we're in radian, and I want to change my y equals to parentheses sine of x, close them both, because they opened a parentheses when I did the sine, so close them both, divided by x. I've already got my table set to ask So it's going to ask me for x coordinates. So I'm going to go to table. Now, I don't have the right x coordinates, do I? That's from the last problem. So delete them. And let's start over. All right, so we want negative 0.1 for the first one. Did you get what I got? 0.99833. Everybody with me? Negative 0.01. And I got 0.99998. Negative 0.001. It says 1. Does it actually equal 1? Then why does it say 1? Because, yeah, there's enough 0.9, there's enough 9s there that it's just rounding it to 1. It can't put them on there. So I'll put 1 because that's what my calculator says. But I know that that's, now it may be to the millionth or whatever, but that's a rounding. Okay, put down whatever your calculator says. Yeah, this calculator's old. Y'all may have something a little different. Now notice what happened then. As x got closer to 0, our y got closer to 1. Even though I wrote down 1, I know that doesn't really equal 1. Okay, so what do we think it's converging to? I think 1. Well, let's see if it really is. So I go to the other end, 0.1. I get 0.99833 again, 0.01, 0.99998. I bet it's going to give me a 1 again, isn't it? 0.001. Oh, clear that. 0.001. Yeah. So, what's our conclusion? We say, therefore, you don't have to put therefore if you don't want to, but therefore, the limit as x approaches 0 of the sine of x over x equals 1. And again, I just can't resist. Wow, I didn't expect that. My calculator just doesn't know what to do there, does it? Yeah, the calculator's confused. I wonder why it's confused. Oh, I did need to put in a 0, didn't I? Well, anyway, we'll look at the graph first then. Or look at it. It really does, as x approaches 0, as x approaches 0, the y really does approach 1. Does it actually equal 1? Sure looks like it, but does it? Must be a little hole there. Okay. I mean, think about it. Doesn't there have to be something there? Because if you put in x equals 0, look at the denominator of your function. It's a 0. Can you divide by 0? No, that's undefined. So your function's got to be undefined at 0, doesn't it? All right, now let me go back and do the table right, just because I got to do it right. Put it 0. Okay. All right. So far, so good. Let's try 19. All right, on this one, the directions say, in exercises 19 and 20, use the graph of the function to decide whether the value of the given quantity exists. If it does, find it. If not, explain why not. All right, so what we've got to do here is put your calculators up. They're not going to help you any. We go by the graph. The first thing they ask us is, what's the value of f of 1? So look at your graph. When the x-coordinate is 1, what's the y-coordinate on that graph? It's 2, isn't it? It's just that separate little point it's a point separated from all the rest of the graph, but it's 2. When x equals 1, y equals 2. So the value of f of 1 is 2. Okay? For part B, the limit of f of x as x approaches 1. Now remember what we talked about in the first part of this lesson. Let's follow the graph. As x approaches 1, so I'm not going to start very far away from 1. I'll start at 0 to the left of it. As x approaches 1, the y-coordinate's approaching about 3.5, something like that. Then I go to the other side of 1, go down here to 2, and x approaches 1. And that y value is approaching 1. It's not converging, is it? I would get 2 separate. If I did my little chart, approaching 1 from the left, I'd get about 3.5. Approaching 1 from the right, I'd get about 1. That means the limit does not exist. So the answer to B is, put D and E, does not exist. I guess I'll put the reason up here, because the graph well, I need more room. The graph approaches different values as x approaches 1. Watch this notation. X approaches 1. That little positive sign above the 1 there, like a superscript, means from the right. And as x, looks like approaches different vowels, doesn't it? Values. As x approaches 1, use a little negative sign as a superscript from the left. Whenever that happens, the limit does not exist. Okay? All right? We good? Part C, what's f of 4? There's an empty dot. So f of 4 does not exist. And I'll finish the reason over here. Yeah. Because, man, I got to get used to writing. Because the graph, what do I want to say? The graph, I want to say does not exist again. Try to avoid using the exact same. Because the graph does not have a value at x equals 4. Blue is B and red is C. And when you write your explanations, I'm not expecting you to write the exact same thing I write. If I do this problem again tomorrow, I probably won't word it exactly the same way. But the big key is for you to be thinking about the reason. Okay? And then D. We need the limit of f of x as x approaches 4. What do you think it is? The limit is 2. As x approaches 4 from the left of 4, the y-coordinates approach 2. As x approaches 4 from the right of 4, the y-coordinates approach 2. The y-coordinate does not equal 2 when x equals 4, but it's sure approaching it. So the limit equals 2. Any questions? All right, let's move on to 25. No, I'm skipped one here. 23 is on this slide somewhere. 23. In exercises 23 and 24, sketch the graph of f, then identify the values of c for which the limit of f of x as x approaches c exists. All right, so for 23, we're going to need to draw this graph. You know what the graph of y equals x squared looks like, don't you? Looks like that. So that's the graph for all the x's less than or equal to 2. So, and I'll say that right there, is 2. And then, from 2 to 4, it's the f of x equals 8 minus 2x. We're not used to seeing it that way. We're used to seeing negative 2x plus 8. So that's a line, okay? And it's a line with a slope of negative 2. And in fact, if I graphed that, we'll pretend that's a slope of negative 2, it'll look like that. Yeah, y'all want me to be accurate here. No, it shouldn't even do that, should it? All right. Now, in the book, you always see these closed circles and open circles. At x equals 2, what does y equal? You just said it. When x equals 2, what does y equal? 4. Because that's the part of the function where x equals 2. So I need to put a closed circle here, open circle here. Now, when I get down here on the linear part of the graph, do I need to put a closed circle at the bottom of that at x equals 4 or open circle? Is 4 in the domain of that little chunk of the graph? It's not, is it? Open, well, it looks closed when I do it. Open circle. All right, and then we have a constant function for x equals 4 and bigger. So closed. So we've sketched the graph. Identify values of c for which the limit exists. How about we identify values of c for which the limit does not exist? That's easier. Where does the limit not exist? 2 and 4. Because what happens at 2 and 4? They don't converge, do they? As x approaches 2 from the left, we're going to one value. As x approaches 2 from the right, it's going to a different value. So the limit doesn't exist there. Same thing happens at 4, doesn't it? So the limit of f of x exists for all values of x not equal to 2 and not equal to 4. Yep. Oh, wait a minute. My graph of the line's not right. Who'd I listen to tell me to put that graph up high? That's the graph of the line. when x equals 2? 8 minus 2 times 2 is 4. Yeah, not bad too. All right, that looks better. All right, we good? Questions? See how all of a sudden the limit does exist for 2 when we draw it correctly? So, all right, last example. Sketch a graph of a function f that satisfies the given values. And they tell us that there are many correct answers. So we'll come up with a correct answer instead of the correct answer. So on 25, we have to graph a function where f of 0 is undefined, where the limit of f of x as x approaches 0 equals 4, where f of 2 equals 6, and where the limit of f of x as x approaches 2 equals 3. All right, got a lot of things to do here. So make you a coordinate plane. Now, f of 0 is undefined. Could be a lot of things going on there. Could be an asymptote. Could be just a hole in the graph. Since it has a limit as x approaches 0, I'm going to make it a hole in the graph because that's pretty easy to deal with. And in fact, so I'm looking at these two things together. Since the value at 0 does not exist, but the limit as x approaches 0 is 4, I'm going to put an open circle at 4, and I'm going to make sure that as x approaches 0 from the left, the y values are going towards 4, and as x approaches 0 from the right, the y values are going towards 4. Now, do I know if it's linear or curved or steep or flat? I don't know any of those things. Okay? Yep. But I've satisfied both of those conditions, haven't I? All right, now, f of 2 equals 6. Okay, so I'm way off scale here, but I need room to draw. F of 2, I need it to be 6. And I need the limit as x approaches 2 to be 3. So, I'll call that 3. So then don't I need for this to happen? And then who knows? Does it do that? Or I don't know what it looks like to the right of 2. But doesn't that, look, let's make sure we've done that. As x is approaching 2 from the left, are the y values approaching 3? Yep. As x is approaching 2 from the right, are the y values approaching 3? Yep. And we've got it. That random dot up there isn't random. That's f of 2 equals 6. How can there be? Because see, if the graph went up there to it, then the limit as x approaches 2 wouldn't be 3, it'd be 6. Right. I don't know what you mean. Is it possible to have it so that that's filled in? Yeah, if they hadn't told us this, then I wouldn't have bothered putting that up there, and we could have had it filled in. Right. Since it's a function, it can't. Okay, I see y'all's issue now. Since it's a function, it can't have a value here and here. because then it fails the vertical line test. It's not a function. It would just be a relation. So that's why there's got to be a hole right there. So that's what it ought to look like. Does that help? Joseph. Because as x approaches 2 from the left, the y values are going to 3. As x approaches 2 from the right, the y values are going to 3. I mean, it might be nice and smooth. I don't know. It might look like that. Like I said, we got a correct answer, not the correct answer. Yes. If this was a test question, there'd probably everybody's graph would look different. Okay? All right. Any other questions? Well, because the only point we actually know is on the graph is this one. That's the only one we actually know. Everything else, I mean, look, it could look so different. It could look like this. Okay? I don't know. I was just piecing it together as I went. All right? Does that help? There's your assignment.